Hello, everybody. This is the solution of the question 19 of algebra section in the course Maths1151 at the University of New South Wales. So this question is about an application of linear system of equations. There are so many applications, and I think this is a nice example, and hopefully we will be able to discuss how we can apply a linear system of equations in our daily life. Here is a question. There exist 4 executives making the regular business trips on 4 routes. Someone suspect that in a company, I presume you assume that you have the company, you suspect that at least one of the executive overstates the expense. The inputs are the number of the trips that each executive made on each route. This is the one thing that you know. Another thing that you know, the total expense claimed by each executive. That's what the number you know. And this is the table given by the executives, A, B, C, D. And these are the routes, 1, 2, 3, 4. And these are the number of the trips that each executive done for each route. So can we figure out someone cheating with these inputs? Now let's try to understand how we can write this mathematically, how we can model this fact in usual life in terms of the maths concepts. So we have basically how we can write this. So we can model this as a linear system of equations. Think about x1, x2, x3, x4 is the cost of the cost that's spent in each route. So since we have the routes are here, right? And the x1, x2, x3, x4, if we think about as a vector, and that represents the cost that's spent in each route by each executive. And then we have the B1, B2, B3, B4. Now, this is what I'm defining. So I'm trying to make this table of the information, and together with the inputs that I have in my hand, I want to write it down as an equation. So first, I need to define what is the representatives of the real world objects inside in terms of the maths concept. So the x1, x2, x3, x4 are the mathematical names or representatives of the event, which is the cost spent in each route by each executive. And then B1, B2, B3, B4, total cost for each executive. If I do that, I will be able to write it down this table as a matrix multiplication. And this matrix multiplication is a linear system of equations, as we discussed, as I've discussed in my class. So M is the coefficient matrix. M is basically this absolutely whole of those, right? That's the matrix 0, 1, 1, 2, 1, 2, 0, 1. These are the number of the trips which is done for each. So this is the route 1, route 2, and so on. X1, X2, X3 are the costs. And if I multiply this row with this column, I will be able to find out B1. B1 is the total cost for each executive, which corresponds to A. Right? So B1 is the expense for each executive. I'm just repeating myself and try to make it clear. So B1, for example, let's focus on only the first one. B1 is the total cost for the executive A. Executive A spent B1, total cost B1, and that person done no trip in the route 1, done 1 trip in route 2, 1 trip in route 3, and he's or she's done 2 trips for the root 4. And each time that person spent different, right? But this x1, x2, x3, x4, basically we don't know, because this is a linear system of equations. This is how we put it up. And if we solve this linear system of equations, we will find out perfect solution for x1, x2, x3, x4. This is what it should be. And then we can compare what executive A claimed for the x1 and claim for the x2, claim for the x3 and x4. Since we have the solution x1, x2, x3, x4, we can compare what the executives claimed, and then we can compare and we can say, oh, this is extremely high, this is extremely low. So we can say that which one is overstating, which one is less stating. Of course, you will set to yourself in business world what is the like an epsilon rate, epsilon error, you would say. If x1 is, for example, 100, you would say probably 110 to the 90 is okay, because not everyone can spend exactly the same. You wouldn't expect that. You would put some discrepancy in the equations. However, with that way, you will be able to find out overstated expenses. I hope this is clear. This is what I've tried to say to here. Solve the linear system of equations for x vector, and then we will be able to, so x1, x2, x3, x4 will tell us what it is supposed to claim. And then, you know, the actual claims of the executives, and compare what it should have been claimed to the what is claimed. And then you would be able to say if there's a huge differences, then you would say, oh, this person is overstates and this person's expenses. Of course, you're looking for the huge differences. With the small differences, you would just say it is just a personal differences between executives, that's all. And yeah, this is a one application that such things can be taught. And the linear system of equations are huge applications. And this is the one of the reason you really must know. You have to know how to solve the linear system of equation. You need to understand what they are and how we put it. It's a very large subject. Yes. That's all for this video. Thank you very much. Yes.